Okay, so make sure you have your tornado handout out. Hopefully you checked your answer key, but I still wanted to make a few comments on that. That was from the last video packet. Here is the homework for after this video, so make sure you write that down. And in the note packet for this video, I included, nope, that's the one we're going to do. There's one to be done. It says in class. It means on this video. The other one, it says practice mean word problems on your own. The answer key is posted. So this in the handout notes is what I'm referring to there. Okay. So the first thing, last video, we ended up talking about the histograms, right? And that you're supposed to have approximately the square root of n for how many intervals. So I wanted to show you why that's important. We do such small data sets in class that you can't really get a feel for it. So I'm going to try to hold this carefully up to the screen. This is an example. I pulled this off the internet, right? This was real life data. It's for Old Faithful Geyser. The data that they collected was not how long it erupted for, but basically how long it stayed quiet in between eruptions. There was something like 225 pieces of data, pretty sure, or 226, so you should have about 15 intervals. So I just want you to look at, these 9 right here. Definitely not 15 intervals. And the problem is, if you don't use enough intervals, it gets very blocky. You really can't see the distribution very well. Now if we go to the back side, and if you look at using way too many intervals, I suppose this was better than the blocky ones on the first page, but it's always looked like almost an EKG or a heart monitor machine to me or something. It's a little too busy looking. So I think one of these up in here is exactly 15 intervals. It's not important, because remember how I kept saying anywhere in the ballpark? Probably any of these 6 right here are perfectly fine histograms in the ballpark of about 15 intervals. And I wanted to show you this too as an example, because I'm going to put up some words on the board in just a minute. But this data for Old Faithful is a fantastic example of what we call bimodal. So see how there seems to be a clump like right in here, but then there's another clump right in here. Something like bimodal data in real life, we always want to look at our data sets. We always want to look at the graphs. We do not do that enough in the classroom just because of time, right? But as soon as I see that something's bimodal, I have to be very careful, because the big topic of this video today is mean and median. If you calculated the mean and median of bimodal, hold on, I can't write in the air. It's going to probably fall, mean or median, it's going to fall in between the 2 peaks. It's almost falling in what I call no man's land. It doesn't describe the slower times, or the shorter times, I should say, the shorter times. It doesn't describe the longer times. So in real life, what we do with bimodal data, we'll actually split the data set in half. Then we'll have an entire conversation about this side, the shorter times, and then we'll have a different entire conversation about the longer time. So it's almost like we have to talk about 2 different graphs. And the only reason we would have known it was bimodal is because we looked at a graph of the data. All right. So we talked about histograms last time. And what I'm about to put on the board doesn't just hold for histograms. It could be stem and leaves or even dot plots. So most books will call it smoothing out histograms, but again, you can smooth out a stem and leaf or a dot plot. The idea is trying to look at a graph and see if it has some general shape. Some data sets don't have a particular shape, and that's okay. But there are some shapes that do seem to come up a lot, and so of course we gave them names. I don't want to mess you up. I want to do the exact ones in the same order that I put on the notes that go with this. Okay, so first it's like, wait, where do curve come from? We haven't done curve graphs yet. So what you can imagine is maybe we had some histogram that looked like that, you know, something like that. And instead of looking at the red bars, I always call it like a ski slope. We just tried to get the general feel, the general curve. We're not going up and down anymore, just the general curve. So after that, we no longer show you the bars anymore. So anytime you see curves like this, you can imagine that there had been a histogram. We just smoothed it out and erased the bars, okay? So this one is called left skew or negatively skewed, okay? It's a negative sign. This one, which if you look at our Instagram histogram from last time, this would be a great example of that. This is called right skew or positively skewed. Then we have, make sure you can see this, symmetrical. Oh, I drew that probably the best I've ever done. Symmetrical. And then just a quick, trying to remind us about bimodal. Bimodal, the two humps do not have to be different heights. They can be the same height. It's just trying to show you that there's two piles, okay? So some real life examples of this. Well, bimodal, we already talked about. Old Faithful geyser, how long it lays quiet in between eruptions. If you did adult, female, and male heights together on the same graph, then it's probably going to look like that. Of course, there's going to be an intersection, but you're going to start to see the taller guys and the shorter girls. Symmetric, well, I'll come back to symmetrical. Left skew. I'm going to be honest, the data sets we do in class, I normally don't see left skew. And I'm just trying to get you to understand what this means. So first of all, most of the data is at the higher numbers with a few low values. You do have to memorize these correctly. Whoever named them a long time ago decided to name them from the tail. See how the tail is on the left? They did not name this for where the big pile is. So left skew means the tail is on the left, meaning not too many data points down there. Most of the data points are at the highest. And so again, right skew, see how the tail is going right? Most people were in the lower numbers with a few people in the higher numbers. Okay, but left skew. I have never checked this, but again, it's not important whether I'm right or wrong. It's more just to get you to understand the curve. I think United States lifespan might be right skewed. I feel like most people in America live to older age. Now, of course, unfortunately, we have some babies and teenagers die early, but I think most people live to older age. How about this? Desired test scores. Desired test scores. We all, you and me, we all desire the test scores to be 90s and 80s and 70s, not too many 20s and 30s, right? Right skew. So, well, this is a fact in real life. You probably don't know it. House prices. I tend to talk about house prices a lot in stats class, mainly because house prices are one of the indicators of the economy. So a lot of times you'll hear them talking about it on the newspaper or, on the internet. And what this is indicating, let's just go with Rockingham County. Most homes are probably, 150,000 to 500,000. And I know those are very different homes, right? But most homes, 150,000 to 500,000. But even in Rockingham County, there are $2 and $3 and $4 million homes. Not that many of them. Most people, have the $200,000, $300,000 homes. Same things with salaries. And usually, so I'm giving you, a usual right now, social media. And you can kind of think about it. If you have a social media account, it makes sense. The lowest you could have is 0. Let's just talk about Facebook. I would think that most people have between, 0 and 5,000 Facebook friends. But then you have the celebrities and stuff with 500,000 or 1 million Facebook friends, right? So, but most people are maybe between 0 and 5 or 10,000. Okay, symmetrical. Well, let's just say you do adult female heights, not the males with them, or you could do adult male heights. A lot of things in biology turn out to be unimodal and symmetrical. Anything manufactured, for example, let's talk about ketchup. I think last time I talked about cider and candy bars or something. Ketchup in a bottle. Heinz or whatever. When they set their machines, think about if you have a 16-ounce bottle. If you put too much ketchup in there, it's going to explode and make a mess, right? If you don't put enough ketchup in there, you're going to be able to start to see how the bottle's kind of empty and nobody's going to buy it, right? So, maybe Heinz knows that they want to put somewhere between like 15.8 and 16.2 ounces in that bottle, and they know that that makes a good bottle. So they know they want to have it centered at 16 ounces. This is actually how they check on every shift, during the day when they're producing ketchup. They'll take, and this goes back to sampling, right, that we were talking about last time. They'll take a sample of at least 30 ketchup bottles. I happen to know it's 30. You don't have to know that. And they're going to measure how much ketchup is in there, and they're going to graph it. And if it does not look like this graph, centered at 16, they're going to shut down the machines and figure out what is broken, why it's not filling up right. So quality control, when something is manufactured, it has to look like that, or it says their machines are broken. Okay, and just briefly I want to talk about SAT scores. Even though SAT scores now have become optional for a lot of colleges, including JMU, most people don't understand this about SAT scores. They are actually forced to look like this. That score that you sent into JMU was not your raw score. It was your scaled score. Don't quote me, I could be 10 points off, but I think the mean, the average that they are looking for on the math SAT is like 510. So on any given Saturday, they get all the scores back, right? And they are going to scale those scores back to fit the curve centered at 510. Let me give an extreme example to make sure you understand what I'm saying. Let's say on some given Saturday, only the geniuses show up to take the SATs, the ones that are going to get 780 and 800 on the math part, right? Well, when College Board or whoever makes SATs, when they get that back, they may assume people cheated, but let's assume they didn't cheat. If only the geniuses showed up and they get all scores back of 780 to 800, they're going to think that they made the test too easy. So they're going to scale everyone back so the average is 510. And that's to try to keep it fair from Saturday to Saturday to Saturday. But let me say it in a different way. On any given Saturday, 50% of people who take the SAT scored below average. 50% scored above average. I can tell you that right now, and I don't even need to know who's taking it, because they take all of the SAT scores, they force it to look like this. And again, I think it's centered at about 510 for the math part. So 50% of students are going to get a score below average, 50% above average. That's what scaled scores are. In a few minutes, we may come back to these 4 pictures to say a little bit more about the mean and median and how they relate. We can just put it back up quickly when we get there. All right, so now we're getting into, so we're moving away from graphs just for a little bit. So moving away from graphs and trying to see if we can describe a data set with just one number. Describe the center of a data set. So hopefully you'll be familiar with these. We have, of course, the mean, the average, right? We add them up, divide by how many? Maybe I should write that. Sum divided by n. What you may not be familiar with is notation. And this is all just how I'm referencing my data set. Like the survey that we had in the last video, if I was using those 45 students as a sample of JMU students, then I would use the X bar notation. If I was using those 45 students as the only 45 students I ever cared about, my population, then I would use the Greek symbol mu notation. So again, this is just notation. If you ever teach Algebra 1, we actually introduce, and it is highly encouraged now in the state of Virginia, to introduce the TI-83s into the Algebra 1 classroom. Where it gets confusing is the TI-83 only gives you that symbol. It never gives you this symbol. But for one data set, these are equal. They both equal. Add up the data points, divide by how many. So I'm making sure you know what capital sigma means in mathematics and statistics. If you know summation notation, you'll know I'm supposed to have an I equal 1 to n. You don't have to write that. I just want to make sure you know that capital sigma means add them all up. So sum divided by n. Add up all your data points, divide by how many. So these are actually the same number. We're going to have a handout maybe next video that it gives you a data set and it asks you the sample mean. And then it says something like, pretend this is a population. What's the population mean? Well, it's the exact same number. Now, in real life, the way we use this notation is we don't know what the true population mean is for, let's say, all Americans. So we take samples, we take the X bar, and we use the X bars to help us estimate the mu. Trying to write down what I said. So X bars, of course, are going to vary from sample to sample because it'd be different data sets, right? And in real life, X bars, we calculate X bars, we take samples, and we get sample means to help us estimate the unknown population mean. Here comes my little star. The mean is affected by unusually high or low values. Let me say it a different way. The mean is not valid for skewed distributions. Say it one other way. The mean is only valid for symmetrical distributions. We'll talk a little bit more about that in a minute. But, so the mean is it's very powerful, but it's limited. We're not allowed to be using the mean for those right skew and left skew distributions, or for example, our Instagram histogram the other day, right? We could see skew on that one. So what are you supposed to do if you can't use that? That's where the median comes into play. So hopefully you remember you have to put the data in order, right? and you're going to take the middle value. I think it's our next video where we'll actually practice this. The median is not affected by outliers, unusually big or small numbers. Okay, so remember how I called it unusually high or low values just a minute ago? A generic word for that is outlier. Because think about it. Here's your min, because it's really just a measure of position, right? Here's your max. Here's your median, cuts the data in half. 50% below, 50% above. So you could take that max and add a trillion to it. It's not affecting the median. You could take the min and bring it down to 0. It's not affecting the median. A few, I guess, synonyms. Most people call the median MED. There is not sample population notation. TID3s, in case you have one of those, calls it MED. It is also called Q2, which stands for the second quartile. We'll talk more about quartiles in a different video. But again, you can think about it, because if you have 2 quarters in your pocket, you have 50 cents, and that's representing that 50%, right? All right, let's go back to our graphs. So if you did print the notes, or if you've been writing along with me, you can just flip back a page. So we had left skew, we had right skew, and we had symmetric. Those are the most important. How do the mean and median relate on these? So I'm giving you general truths, right? I'm sure someone could create a data set that goes against it, but in general, let's talk, I'll go in order. Let's talk about the left skew first. Most of the data is up here with a few low values. This would have been if I had left all those zeros on my social media survey, right? By the time you add in a bunch of zeros and divide, your mean is going to be pulled downwards. So in left skew, in general, the mean is less than the median. That's very important. You have to memorize these. Hopefully you understand them. Right skew, it's probably even easier. Think about my Facebook I was talking about. Most of us are probably 0 to 6,000, but then you have some celebrities with 1 million Facebook friends. Imagining adding 1 million to 2,000s and 3,000s. It's going to make that sum get so big, it's going to pull up the mean. So the mean turns out to be bigger than the median in right skew. If you want to know the easy way to remember this, is that the mean follows the tail. The tail's going to the right, the mean is getting bigger. Here, the tail's going to the left, the mean is getting smaller. That's the easiest way to remember it. On symmetrical, well, theoretically they'd be exactly equal. Real data is never perfect, so we're going to say the mean is approximately equal to the median. And these are important because sometimes we'll read in the newspaper and they'll tell us the mean and median, but they don't show us a graph, right? But knowing what the mean and median are, we can then take a guess as to what the graph look like. So sometimes we'll use this in the opposite direction. All right. Now though, so mean and median, not hard. You probably already knew how to do all that. Maybe a little new notation. But how do you make anything harder? Well, you get word problems. So we're going to enter into what I call our mean word problem topic. This is probably the first spot where some students start to struggle. We're going to do 3 or 4 examples in the video, and there's another 3 on that handout that you could practice and then check the answer key. The true title is the weighted mean. Okay. Now, before we even start, let me just give you a little bit of, not motivation, but you already know some of this stuff, right? Because you're in college. Hopefully, you're aware of this, that, well, if you take my class, it's a 3-credit class, right? And let's say you get a C. And let's say you're taking a 1-credit rock climbing and you get an A. Hopefully you know you don't get to average those two together and say you have a B, because the 3-credit is worth so much more than the 1-credit. So when you're in college, the weights is actually the credits for each class, right? Well, we're going to start with some what I call the cheesy examples, things you could imagine came right out of like a middle school textbook, but we have some GPA problems we're going to work also. A lot of this is just experience. Sometimes I call it putting tricks, bag of tricks. So you know how the mean is the sum divided by n? Honestly, that's not the most useful. Now, this is a formula. We can rearrange it. Let's multiply both sides by n. So you're going to find that we're going to use this a whole lot, because the sum level, you're allowed to do anything you want to it. You're not necessarily allowed to play with the mean level. But let's start a problem and I'll show you how this works. Actually, I'm not going to write the whole problem. I'll put up the answer, right? But the mean word problems in class, this was part of this document file for this video. So read number 1. I'm just going to write the highlights up here. Okay, so they get, this was, what did I say? Cell phone contacts or something. They tell me the mean for the boys and the mean for the girls. And I'm like, I didn't care about that. I just wanted the mean for all 26 people. Now, I definitely do want you to think about what you think the most common wrong answer is. Okay? The most common wrong answer is just to average the averages. 205 plus 312 divided by 2. Some people will do 205 plus 312 divided by 26. That's not right either. But the 205 plus 312 divided by 2, that's like that 1-credit kinesiology and your 3-credit math 207, thinking that averages to a B, and it doesn't. Is there ever a time you could do 205 plus 312 divided by 2? Well, yes, if they're the same weights. If you're taking my class and you're taking 3-credit Education 300 or something, you do get to average those 2 grades because they're both 3 credits. So if this had said 18 boys, 18 girls, yes, you could just average those 2 numbers. Or if it had said 8 and 8, but it doesn't. The boys have so much more weight. So this is where this is coming very handy. We can put the sums together. So since this is our first one, I'm going to kind of overkill this a little bit. Let's work on getting the sum of the boys. So this is the n times x bar. When I'm trying to get the sum of the boys, right? And then whatever that number is. And then I could do the sum of the girls. So that's my n times x bar. So I'm putting my sum of the boys plus the sum of the girls, which, yeah, equals the sum of the human beings, right? And I knew I had 26 human beings. I'm going to overkill this one again, because sometimes being super organized is going to help you not make a mistake. These are the weights, the 18 and the 8. In this case, these were the n's, right? If you add those together, it better equal what you're getting into the denominator. We already knew it was 26 people, but that's the way to make sure we haven't forgotten anything. Stick this into your calculator. It's always helpful for you to know if you have a ridiculous answer, meaning you hit a wrong button on your calculator or something, right? So think about what you know the answer, well, an estimate of the answer. The answer has to be between 205 and 312. Actually, the answer has to be closer to the 205 because the boys had more weight. So like if you get an answer of 300 out, that cannot be right. Redo it. This turns out to be 237.9. Oops, 237.9. Do not round that to 238. Right now they still say the average number of children Americans have is 1.6 kids. No one is having 1.6 kids, right? But that is the way we talk. So keep 1 decimal place there. All right. Let's do another part, but we're just going to be worried about the boys this time. So I'm actually even going to just erase the girls to give me more room. Okay. So read part B. All right, so we just are talking about the boys, and it seems like we want to kick 2 of them out of our data set. Again, you're not allowed to just subtract the 10 and the 20 from the mean. You can't do that. You have to get back to the sum level. And at the sum level, you can do anything you want because that number, that's where the 10 and the 20 originally went into, whatever that big number was, right? So I'm going to kick 1 boy out who had the 10. I know I don't have to show that one mathematically. It just helps remind me, yes, I'm kicking 1 boy out. You know, I had 18 boys at their average. I'm kicking 1 boy out with his number. Gotta make sure I read my problem right. I'm kicking 1 more boy out who had a 20. And again, the problem does say, what's the mean for the other 16 boys? But let's make sure you know where that 16 came from. Yes, I had 18 minus 1 minus 1. Yes, that gives me 16 because I kicked those 2 out of my data set. So if you do that math, think about what answer you should be getting. These were probably very low numbers. If on average is 205, those boys had probably just gotten a new phone or something. They were probably making the data set left skew, so they were pulling the mean downwards. So if we kick them out, I bet you that mean is going to come upwards, become higher, which it does. Gives you 228.75, which is higher than the 205, which is what I was expecting. Okay. Let's bring this back and show you how it relates to GPA stuff. It just looks a little bit different, but I swear to you, it's the exact same stuff. We're going on to number 2 on this handout. Okay, so we got Anne. She's taking 15 credits. All right, so apparently in the past, she has taken 18 credits and has a GPA of, and I'm keeping so many decimal places because my Madison is that picky. I can't remember if my Madison is 3 or 4 decimal places, but you better believe JMU, my Madison, does not round your GPA to 2 decimal places. So we're going to keep all of our decimal places. Okay, so now she's taking 15 credits. They're asking us what GPA does she need. That then cumulative, meaning end of the year, she will have a 3.5999. Okay. So think about what GPA even stands for. Grade point average. So these are the X bars, right? So we got to get back to the sum level. Think about how your GPA is calculated. All right, she took 18 credits and she had a 3.999. There is that N times X bar, just showing you that the pattern is exactly the same. Here it's credits instead of number of boys, but it's the same thing. Plus, she's taking 15 now, but here we're going to have a little bit of algebra. They're asking me what GPA does she need this semester. So I just put in X, to represent the GPA. So this is the N times that X bar, the GPA, right? Now at the end of the semester, think about it. How many credits has she actually even earned? 33. So we would divide that by 33. And what do they want her to have? They want her to have the new GPA, 3.5999. So this is just putting the unknown over here instead of over here like we had with the boy problems we had just done. So you do have to do some algebra. When we're in the classroom, I usually get you guys to try to solve this, and then we give you some algebra hints. So you should pause the video right now, see if you can solve it, and I'll give some hints when you come back. All right, so, well, maybe I should put up the right answer so you'll even know if you got it. 3.8399 is the answer, okay? So your first step, in case you don't have that, I want to talk you through the algebra. You're going to multiply both sides by 33, okay? So those 33s cancel out. Let me write that over here real quick. And I don't know that I have my intermediate work, so also, you know, that's just begging to be multiplied. Let's figure out what that is. $61.1982 plus 15x equals, let's figure out what that is. And I'm keeping all my decimal places. I'm not rounding. If you start rounding up in here, your rounding error is going to accumulate and you are not going to get the right answer. So now you're going to subtract that from both sides, right? Okay, so you're going to have 15x equals 57.5985. And now divide both sides by 15. And you will get that answer. All right. Yeah, let's do your 207 grade, and then we'll do the longest problem there is. I'm trying to do the harder ones on this video. The ones on the handout that I've assigned are not as involved. Okay, so my summer syllabus is a little bit different, particularly online, a little bit different than spring. So, okay, I printed my syllabus. Let's see. Oh, yes. We're going to have some mandatory WebEx meetings, so as long as you attend those, it's kind of like attendance, right? Is 10%, 3 tests, 23% each, and the exam is 21%. Okay, I just don't want to forget what my percents were. All right, we're going to set up the entire formula of how to calculate your grade in my class. I do not use Canvas to actually calculate your grade because we only have 4 grades anyway, right? But then a lot of students are concerned with how do I calculate my grade at some given point. We'll do a little example on that. But this is exactly what I type into my Excel spreadsheet. Okay, WebEx. So first, would you like to be a positive thinker? I'm assuming you're going to come to the WebEx meetings that we have. So you can go ahead and put a 100 in there for you, right? If you think you're going to skip some, well, you don't get 100, but let's be positive. So I'm going to put 100 in there for you. Then we have test 1. Then we have test 2. Then we have test 3. And then we have the exam, and that equals your final grade, right? So let me see, 20, 40, 60, 69, 79, yes. All right, now, if you look at this one, you might say, well, the last few problems, you always seem to have a fraction. There always seemed to be a denominator. Well, those were our weights, right? What is 0.1 plus 0.23 plus 0.23 plus 0.23 plus 0.21? It would equal 1. If you like, you could then divide by 1 if you still like to see that fraction form. Let me say it slightly different though. Sometimes after I teach students this, they say, well, your syllabus is easy. It's out of 100%. I have a professor and their syllabus is like out of 600 points or something. You know, you could think about my syllabus out of 100 points if you wanted. I mean, and you could then put 10 there, 23, 23, 23, 21, all divided by 100. That's how you do a point syllabus. Let's say you're a history professor. Maybe test one was 150 points out of a total of 600. Well, then the weight here would be 150, and you would have that denominator out of 600. So what I'm teaching you here can easily be applied to a syllabus out of points. You should always check your grade because we professors are human and we can make mistakes. We're the ones programming Canvas and or type in our numbers into Excel or things like that. So you should always know what your grade is and be able to check it. I thought I was going to say one more thing. Well, no. But as Maymester goes, you'll be able to start putting your grades in right before the final exam. You're going to have number plus 0.21 times exam equals your grade. And that's when sometimes students, oh, if I need a C in the class, what do I need to make on the exam? Or if I make a 40 on the exam, what grade am I going to get? You can play with it like that. Let's do a little example though. Because sometimes maybe just even after test, well, we'll do it after test 2. Let's say on test 1, you get a 72. On test 2, you get an 89. And we are still going to have your attendance at 100. We want to know what's your current grade. On that day, after you get your test 2 back, you'd like to know your current grade. All right. 0.1 times 100 plus 0.23 times 72 plus 0.23 times 89. Now this is where then I start to take emails. Students do that part. Well, let's do that part first. Let me show you the emails I take. That gives you 47.03. And students start emailing me saying, I did your formula, but I know I don't have a 47 in your class. Yeah, you don't have a 47 in my class because what did you forget to do? You haven't done 100% of my class. Here are your weights. You've actually only done 56% of the class. So make sure you then divide by, remember how I've been teaching you to add up the weights because that should give you the denominator. Make sure you divide by 0.56. And you get 83.98. That is your current grade in the class. Yeah, which is much higher because if you had just averaged these two, it would be like an 80.5, but having 100 in for attendance helped you pull it up. So don't forget that part. All right, so this is again a time that I do beg you to pause the video, work really hard, try to show all of your work for number 4, and then come back. And if you absolutely don't get the answer, when you come back to the video, you can listen to me do it a little bit and then pause it again to then see if you can finish. So go try number 4. It is the longest. There are some common mistakes most students make, but that way you'll know, are you making the common mistakes? Did you, make a lot of mistakes, something silly? So give number 4 a try before you watch me do it. All right, I'm getting my papers organized. Okay, so she's taken 45 credits, has a GPA of that. She's currently taking, so let me try to, she's taken 45 credits. She has this GPA. The 15 credits she's taking, there's a few different things that's happening. I don't like this blue, hold on. One 3 credit. So a 3 credit class, she's doing repeat forgive. She had gotten a C, but she plans to get a B this time. So repeat forgive, once you retake the class, they will kick that C out of your GPA and replace it with the B. The thing is, and one of the common mistakes students don't realize, JMU is not going to give you credit for taking the class twice. They're not going to give you 6 credits for taking the same class, so keep that in mind. Now the other, the other 12 credits, and they're asking what GPA. To have a cumulative GPA at the very end of a 3.0000. Okay, so we're just building on what we did on that GPA problem from a few minutes ago. She has taken 45 credits, okay? But this whole repeat forgive thing, we have to kick out her old grade. Now here's where the numbers are also similar. It gets very confusing. This is the N, the number of credits. It was a 3 credit class. This 2 is representing a C. Think about it. If you've made all C's at JMU, your GPA would be a 2.00, right? So C is worth 2. We're going to kick out that bad grade, but now we're going to put her new grade in. So this was the credits part, that 3 credit class, the repeat forgive, and this is what a B is worth. If you've earned all plain B's at JMU, you have a 3.0 GPA, right? So that's just making sure you know what each one of these numbers is representing. So that's the whole repeat forgive part. But she's got 12 more credits she's taking. And yeah, the question is, what does she need to make? Now, here is particularly a way why I've been trying to teach you, make sure you add up your weights. 45 minus 3 plus 3 plus 12 does not equal 60. It equals 57. So a very common mistake is for students to just see that 45 and 15 and think a 60 goes here. But if you'll use your weights, you'll see that that's not a 60, it's a 57. Because we're not going to give you credit for taking the same class twice, right? We're not going to give you 6 credits. So you don't get to get those extra 3 credits. The other common mistake is a lot of students forget that these were 3 credit classes. They put number 1s there. So make sure you had your 3s there. Then, okay, it said we had to have a 3.0 GPA. So then from here, it's also algebra. You know, this is all number here. Figure out what that is. Also, at some point, you want to multiply both sides by 57. Eventually, you're going to divide by 12. So your final answer should be 3.425. That is the GPA that she needs from her other 12 credits to end up with a 3.0. This is all very real life stuff. This was motivated by nursing students. They cannot even turn in their nursing application unless they have a 3.0000. Nursing will not accept their application if they have a cumulative GPA of 2.9999. They don't round up. So a lot of the nursing students will use the repeat forgives, either in Math 220, Chem 120, something like that. And so a lot of times I have to work this stuff for the students. They ask me, okay, I'm doing a repeat forgive. What else do I need to do this semester so I can turn in my nursing application? There's a lot of majors here that need a particular GPA to get into the program or things like that. Even education. Unfortunately, I don't have it memorized though. I did realize that maybe I may have said at the beginning to have your tornado handout out. I think I'm going to hold that for the next video. Again, please use the answer key on Canvas and know that we are going to discuss the tornado handout next video. All right, make sure you work on your homework, redo these mean word problems, because again, this is the first spot in the whole stats module where some students start to struggle.